All right, in 3.3b, we're looking at what's called the remainder theorem and the rational root test. Now, the remainder theorem says this, that if f of x is divided by a factor, remember that's k is what we're dividing by, right? Then when you do it with synthetic division, you figure out your remainder. The remainder is the same number that you would get if you plugged that k value into the original equation. So we're going to use the remainder theorem to evaluate the function at the given value. So just like synthetic division, you're going to make sure you're in exponent order and pull your coefficients down. So I'm going to go 2, 0, 7, negative 7, and 3. Okay? X cubed, x squared, x, and then no x. All right? And I'm dividing by whatever I'm evaluating at 1. So let's figure this out. If I drop the 2 down, multiply. 2 times 1 is 2. 2 times 1 is 2. Negative 7 plus 2 is negative 5. Negative 5 times 1 is negative 5. And that gives me a remainder of negative 2. So what does that mean? It means f of 1 equals negative 2. If I plugged a negative 2 into or a 1 into this equation up here, I would get a negative 2. All right, so let's try this with b. Same thing, same coefficients. And I'm going to divide this time by negative 2. Bring the 2 down. 2 times negative 2 is 4. 0 and negative 4 is negative 4. Negative 4 times negative 2 is positive 8. Negative 7 plus 8 is 1. 1 times negative 2 is negative 2. 3 minus 2 is 1. So that means f of negative 2 equals 1. That's my answer. All right, so now we're going to evaluate the same thing with 1/2. So I'm going to go 2, 0, negative 7, and 3. Don't let the fraction scare you. Bring the 2 down. 2 times 1/2 is 1. 0 and 1 is 1. 1 times 1/2 is 1/2. Now I need to get a common denominator. Make 7 into halves, so it would be negative 14 halves. Plus 1/2 is negative 13 halves. 13 halves times 1/2 is a negative 13 fourths. All right, so then convert 3 to fourths, that would be 12 fourths minus 13 fourths gives me a negative 1/4. And that's the answer. So f of 1/2 in this equation gives me a negative 1/4. All right, so there's some fractions you got to think through, but it's not every problem, and you should be able to handle it. The next type, I should say, says use synthetic division to show that x is a solution. Okay, you're going to know x is a solution if you get a remainder of 0. Okay, that means the remainder equals 0. And then factor it completely. Okay, so we're going to take that x, factor it down, and then finish factoring it till we know all the roots of the equation. So we're going to start with 4 and use synthetic division. So 1, there's no x squared term, so I'm going to put in a 0, negative 13, and negative 12. All right, so bring the 1 down. 1 times 4 is 4. That's 4. 4 times 4 is 16. Negative 13 plus 16 is a 3. 3 times 4 is 12. So I get 0. All right, so this was an x cubed term, so this is now x squared plus 4x plus 3. And I can factor that. It's just going to be x plus 1 and x plus 3. So if I solve that, I get x is negative 1, x is negative 3. So then all my solutions are x is 4, negative 1, and negative 3. All right? So let's try another one. Same thing. Bring your coefficients down. 2, 1, negative 5, and 2. Now they gave it to me in a factor form. So what does that mean? That means x is negative 2. So I'm going to divide by negative 2. Bring that 2 down. 2 times negative 2 is negative 4. Negative 3. Negative 3 times negative 2 is positive 6. Gives me a positive 1, negative 2, and 0. Now if I reduce this, this will be 2x squared minus 3x plus 1. That does factor to 2x minus 1 and then x minus 1. So if I solve that, 2x minus 1 is 0. So x is equal to 1 over 2. And this solves down to x is equal to 1. So my solutions are 1/2, 1, and negative 2. Okay? Third power means I'm going to have 3 roots. There they are. Yet another one. All right? So look, this is in factor form, so I need to solve that. So think about this. This is going to be 2x equals negative 1, divide. So the x value I need to use is a negative 1/2. My coefficients down, I get 6, 41, negative 9, negative 14. Let's see what happens here. Bring the 6 straight down. 6 times a negative 1/2 would be a negative 3. Negative 3 times a negative 1/2 is positive 38. Negative 1/2 times 38 is going to be a negative 19. That gives me negative 28. Negative 28 times a negative 1/2 gives me a positive 14. Phew, came out pretty. There we go. Now, this was x to the third, so let's do this. 6x squared plus 38 minus 28. So I might use a good old quadratic formula on this, or if you want to factor out a 2, we could make these numbers a little bit smaller. 19. All right, so let's use quadratic formula here. I'm going to do negative 19 plus or minus the square root of 19 squared. 361 minus 4 times 3 square root of 529 divided by 2a. Thankfully, square root of 529 is a nice 23. So we can figure this out. So negative 19 plus 23 over 6, negative 19 minus 23 over 6. So that gives 4 over 6, which is 2 over 3. So my roots are a negative 1/2, 2/3, and a positive 21. That's a crazy one. Oh, that'd be negative 21, sorry. All right, last but not least is what we call the rational zero test. So if you're looking at this going, I don't even know where to start. What if they don't give me zeros? How am I supposed to know? There's what's called the rational zero test. So you can know the possible rational zeros by looking at the factors of the constant term. Now the constant term is the last term without an x. Factors of that and divided by the factors of the leading coefficient. So in this case, the constant term is a negative 3. So factors are numbers that multiply to give you 3. Well, there's plus or minus 1, plus or minus 3. And that's really it for 3. This is an easy prime number, so there's only a couple options. Then we divide it by the factors of the leading coefficient. Well, that's just a 1. So it's just plus or minus 1. Not a big deal. All right, so where do you begin? Well, okay, so once you've reached the point where you have ideas of what the roots are, the next thing you're going to want to do is go into your calculator and graph those roots, or graph the equation to see where do those roots line up. Using that graph, that'll help you narrow down, instead of having to check every single possibility, it'll help you narrow down which places to start with. So with this one, the first root that we see going left to right is negative 3. So I would start my synthetic division with negative 3 because I know it should come up with a remainder of 0. And that'll help me have better time management instead of trying all these numbers that don't work. That 1 times negative 3 is negative 3. And I get 0. 0 times that is 0. Negative 1 times negative 3 is positive 3. And now I get 0. So check, check, this worked. All right. So now I'm going to use what I have left. I have x squared minus 1 left. Well, hopefully we know that that factors into x minus 1 and x plus 1. And that will solve nice and neatly. So x will equal 1, negative 1. And don't forget your root that we actually found was negative 3. All right. So when you have a rational root zero test problem, You start by finding the potential roots and then start testing them. It is kind of messy and it can take up space, but don't be afraid. Okay, you will find the root. Hope that makes sense, and we'll see you in class.